Hello everyone, hope you're doing well. My name is Tawfiq Omer Usman, math teacher. In this video, I will explain Chapter 1, Lesson 3, Part B, Domain and Range of the Polynomial Function. Domain and range of a function. Domain is the set of the value of all x which make the value of y defined. For all x belong to real number when y is defined. That means that y must not equal any number over 0, like 4 over 0, 3 over 0, etc. Or y not equal square root of negative number, like square root of -4. In the graph, to find the domain of any function, the first point in the left, draw a vertical line on x-axis. And from the end of this function in the right, draw another vertical line on x-axis. This interval from here to here is called a domain of the function. Range of function is the set of all value of y which we get it by replacing value of x to the function form. In the graph, from the lowest point in the graph, in the bottom, draw a vertical line on the y-axis, and in the higher point, draw another vertical line on y-axis. This interval from here to here is called a range of the function. Domain and range. To find the domain and the range of a function, we classify them in two groups. The first group is algebraical function, which classify to polynomial function, radical function, and rational. First of all, we must take a polynomial function. We classify the polynomial function into two groups. The first one, if the degree of the polynomial is odd, then the domain and range is equal to real number r. For example, see this graphic. You can see that the domain is all real number and the range is all real number. In this one, the domain is all real number and the range is all real number. The second type, when degree of the polynomial is even. Here, we are interested in the quadratic function. So, first of all, find the vertex of the quadratic function or polynomial fx equal ax squared plus bx plus c. Vertex h is equal x equal minus b over 2a, and vertex is hk point. Use the value of x to find the value of y, which is equal to k. Then domain is real number and the range is start from k to the positive infinity if a leading coefficient is positive. That means if a is a positive or before x squared is positive. And the range is start from minus infinity to the k if a is less than 0, which means leading coefficient is negative, or we have a negative sign before x squared. If the a is positive, the parabola of the quadratic function is opening to the up. Therefore, the range is begun from k or y of the vertex to the positive infinity. And if the leading coefficient is negative, then the parabola it be opening to the down. So it began from minus infinity to the k. Example number 1. Which interval below is the range of the function f of x equal x squared plus 2? The domain of this function is all real number. As we know that the polynomial function, their domain is real number. Here, because we haven't an x with the power 1, then h is equal to 0. H is equal to 0. And this number, the constant term, is k. Therefore, the vertex is 0, 2. The vertex is 0, 2. And because the leading coefficient is positive, therefore the range began from 2 to the positive infinity, which closed into and open in positive infinity. If we draw the graph of this function, it's like this. As you can see that the range began from the lowest point, it is 2, to the highest point is positive infinity. That D is a correct answer. Example number 2. Which interval below is the range of the function f of x equal x minus 2 square minus 1? This is a quadratic function. Therefore, comparing this function with the f of x equal x minus h squared plus k, then we get that h is 2 and k is minus 1. Always we will take the h with the different sign. Here you have negative, you take it positive. Therefore, h is 2, but for the k we are taking the same sign, is minus 1. Therefore, h is 2 and k is minus 1 and vertex is equal to minus 1. Because the sign before the bracket or a leading coefficient is positive, therefore the range began from minus 1 to the positive infinity. That means D is correct answer. If we draw the graph of this function, it's like this. As you can see, it began from minus 1 to the positive infinity. Example number 3. Which interval below is the range of the function f of x equal 1 minus x minus 2 square? First of all, write the function in this way, f of x equal minus bracket x minus 2 square plus 1. As we said, we will take 2 is the value of h and plus 1 is the value of k, and because the leading coefficient is negative, then it starts from negative infinity to the 1. Negative infinity to the 1. Then range is minus infinity to the 1. That means C is a correct answer. If we draw the graph of this function, it's like this. As you can see, the range is begun from minus infinity until 1. Example number 4. Which interval below is the range of the function f of x equal 2 minus x squared? Here, we write the function in this way, f of x equal minus x squared plus 2. Because we haven't an x with the power 1, therefore h is 0 and k is 2. Therefore, the vertex is 0, 2. Because the leading coefficient is negative, therefore it starts from negative infinity to the 2. Negative infinity to 2. Therefore, C is a correct answer. Example number 5. Which interval below is the range of the function f of x equal x squared plus 2x? If x is equal x squared plus 2x, to find the h, we use the value a is 1 and b is 2. Then x is equal minus b, which is minus 2, over 2 times a is 1, it equal minus 1. Then h is minus 1. Replacing minus 1 in the function to finding y is equal f of minus 1, which equal minus 1 squared plus 2 times minus 1, which equal minus 1. Then vertex is minus 1h and minus 1k. Because the leading coefficient is positive, or the sign before x squared is positive, therefore the range is begun from minus 1 to the positive infinity, as you can see in the graph of the function, from minus 1 to the positive infinity. Range is minus 1 to the positive infinity. B is a correct answer. Which interval below is the range of the function f of x equal 3x squared plus 12x plus 4? All polynomial functions, their domain is R. But to find the range, first of all, find a and b. A is 3, is bigger than 0, is positive, and b is 12. X is equal minus b, which means minus 12, over 2 times a, 2 times 3. Minus 12 over 2 times 3 is minus 2. To find y is equal f of minus 2 equal 3 times minus 2 squared plus 12 minus 2 plus 4, which equal minus 8. That means the vertex is minus 2, minus 8. And because the leading coefficient is positive, therefore it began from minus 8 to the positive infinity. That means D is a correct answer. Example number 7. Which interval below is the range of the function f of x equal x to the power 4 minus 5x squared plus 4? Comparing with the general form, you get that a is 1 and b is minus 5. Here we cannot find x with the power 1, but we can find x squared. Therefore, x squared is equal minus b over 2 times a. Minus b is minus 5 and 2 times a is 1. Therefore is 5 over 2. And now taking square root for both sides, then x equal plus or minus square root of 5 over 2. Then y is equal minus 9 over 4. Here we have two vertices. The first one is minus square root of 5 over 2 minus 9 over 4. The second one, square root of 5 over 2 minus 9 over 4. Because of the leading coefficient is positive, therefore the range began from minus 9 over 4 to the positive infinity. That means D is a correct answer, as you can see in the graph, from minus 9 over 4 to the positive infinity. Example number 8. Which interval below is the range of the function f of x equal minus x minus 2 square? F of x equal minus x minus 2 square. Comparing with the fx equal x minus h square plus k, you can see that a is minus 1 less than 0, that means negative. H is 2, we can write here plus 0. Therefore, the h is 2 and k is 0. The vertex is 2, 0. Because the a or the leading coefficient is negative, then the range began from the negative infinity to the 0. That means C is a correct answer, as you can see in the graph of this function. As we said before, the domain of all polynomial function is real numbers. Example number 9. Use the graph of the fx and gx. Which of the following interval is domain of the fx? To find the domain of any function, we start from the start point on the left and draw the vertical line on the x-axis and read the value of x. The value of x here is minus 6. And draw another vertical line from the last point on the right and read the value of x. As you can see, x is here 5, but because we have a wholly point, then 5 is not domain. Then the domain is start from minus 6 to the 5, but 5 it be opened. The correct answer is C. Use the graph of the fx and gx. Which of the following interval is the range of fx? This time, in the start point, we will draw a vertical line on the y-axis, like this, and read the value of y. As you can see, the value of y is near 3.5, 3.5, and draw another vertical line from the lowest point. As you can see here, we have lowest point. Draw here a vertical line on the y-axis and read the value of y. The value of y is 1. Then the range of f is 1 to the 3.5. That means A is a correct answer. Question number 11. Use the graph of fx and gx. Which of the following interval is domain of gx? First of all, draw the vertical line on x-axis from start point on the left. It is a wholly point, therefore the value of x is not equal minus 2. And draw another vertical line on x-axis from the end point on the right and read the value of x is 4, therefore x is equal 4. The domain starts from 2 to the 4, but into it be open. Domain of G is minus 2, 4 there. Here is open and here is closed. The correct answer is B. Example number 12. Use the graph of the fx and gx. Which of the following interval is range of gx? Here, draw a vertical line on the y-axis from the higher point on the function and read the value of y. Here the value of y is near to the 2.25 and draw another vertical line on y-axis, the correct answer is D. Here we came to the end of the video. Please share it with your friends so that everyone gets benefit. Please write your comment and subscribe the page. And also press like and ring the bell